What is transverse shear and material breaking? Have you ever wondered how materials break under stress? One fascinating aspect is transverse shear. This type of failure happens when forces act parallel to the cross-section of a material. Imagine a beam being pushed or pulled in a way that tries to slide one layer over another. This sliding occurs across a plane that is perpendicular to the length of the material. When forces are applied, they create internal shear stresses. If these stresses exceed the material's shear strength, failure occurs. Picture a beam bending under a load. While it experiences tension and compression along its length, it also faces transverse shear stresses across its width. These stresses are most intense near the neutral axis, which is the middle layer of the beam. The way transverse shear affects materials can vary based on their properties. For isotropic materials, like steel or plastic, shear stresses are usually lower than the stresses along the length. Therefore, failure often happens due to tensile or compressive strain instead of shear. On the other hand, anisotropic materials, such as wood or composites, behave differently. Wood is much stronger along its grain than across it. This means that transverse shear stresses can lead to splitting or crushing along planes that are perpendicular to the grain. Even with moderate bending, cracks or breaks can occur. Transverse shear failure can show up in a couple of ways. One is shear fracture, where there is a clean break along the shear plane. Another is crushing or splitting, especially in layered materials where fibers may separate or compress under shear. In engineering, understanding transverse shear is essential for designing components that can withstand shear forces. This includes beams, fasteners, adhesives, and joints. For instance, when using adhesives, the shear strength of the bond must be strong enough to resist transverse shear loads. Testing materials for shear failure modes can reveal weaknesses that might not be obvious under tension or compression. This knowledge helps engineers create safer and more reliable products. In essence, transverse shear and material breaking is all about how shear stresses act across a material's cross-section. This leads to sliding or separation along planes that are perpendicular to the main axis. The significance of this failure mode varies with the type of material and the conditions it faces. Understanding it is key to preventing mechanical breakdowns and product failures in both engineering and natural materials.